Diamonds. One of the hardest and most valuable materials ever discovered on Earth. They symbolize love, power, luxury, and wealth. From engagement rings and high-end jewelry to advanced cutting tools and modern technology, diamonds are everywhere. But here's the question most people never ask. Where do diamonds actually come from? Are they really formed deep inside the Earth? How does carbon, one of the most common elements on the planet, turn into something so rare, strong, and expensive? The truth is, diamonds don't form in factories. They aren't created overnight, and they don't come from just anywhere. Diamonds are born more than 100 miles beneath the Earth's surface, under extreme heat and pressure that exists nowhere else on our planet. They take billions of years to form, and bringing them to the surface requires some of the most powerful natural forces and advanced human engineering ever developed. In this documentary, we're taking you deep underground to uncover the entire journey of a diamond, how diamonds are formed inside the Earth, how volcanic eruptions push them to the surface, how miners locate and extract diamond-rich rock, how rough stones are cut and polished, and how a dull crystal becomes a brilliant diamond worth thousands or even millions of dollars. This is not just a story about jewelry. This is a story of geology, pressure, time, science, and precision. From the depths of the Earth to the brightest display cases in the world, this is how diamonds are made. Diamonds don't begin their journey in factories, laboratories, or jewelry workshops. They are born deep inside the Earth, far beyond where humans can ever dig. In fact, most natural diamonds form more than 100 miles beneath the Earth's surface, in a region known as the mantle. This part of the Earth exists under conditions that are almost impossible to imagine. Temperatures here can exceed 20 degrees Fahrenheit, and pressure is more than 50 times greater than atmospheric pressure at the surface. These extreme conditions are absolutely critical. Without both intense heat and immense pressure, diamonds simply cannot form. At these depths, carbon, one of the most common elements on Earth, behaves very differently than it does on the surface. Under normal conditions, carbon forms materials like coal or graphite. But deep inside the mantle, pressure forces carbon atoms into a completely different structure. Instead of loose layers, carbon atoms are compressed into an ultra-tight crystalline lattice. This atomic structure is what gives diamonds their legendary properties: incredible hardness, extreme durability, high thermal conductivity, and their ability to reflect light so brilliantly. Every diamond is essentially carbon locked into its strongest possible form. What makes this process even more remarkable is time. Diamonds do not form quickly. They take millions to billions of years to grow. Some of the diamonds mined today are older than dinosaurs, older than the first plants on land, older than most life on Earth. They formed during periods when the planet itself was still evolving. But diamonds don't form everywhere in the mantle. They only develop in very specific zones where carbon is present. Temperatures remain stable. Pressure remains consistently high, and the surrounding rock chemistry is just right. This is why diamonds are so rare. Even deep underground, the conditions required for diamond formation are uncommon. And even when diamonds do form, they remain trapped inside solid rock, completely invisible, buried far beyond human reach. Another important fact many people don't realize is that diamonds are not molten when they form. They don't start as liquid gemstones. Instead, they crystallize slowly within solid rock, growing atom by atom over immense periods of time. Some diamonds may grow as tiny crystals, others may slowly expand into larger stones. But all of them remain hidden, locked inside the mantle, with no path to the surface on their own. This raises an important question: if diamonds form so deep underground, how do they ever reach the Earth's surface? The answer lies in some of the most powerful natural events in our planet's history: violent volcanic eruptions. Not the kind of volcanoes we commonly see today, but ancient, deep-rooted eruptions capable of ripping material from the mantle and blasting it upward at incredible speeds. These eruptions create rare volcanic structures called kimbolite and lamproite pipes. These pipes act like natural elevators, transporting diamonds from depths of over 100 miles to the Earth's surface in a matter of hours. Without these eruptions, diamonds would remain buried forever. Most diamond-producing regions on Earth, including parts of Africa, Russia, Canada, Australia, exist specifically because ancient kimbolite eruptions occurred there millions of years ago. Even today, diamonds are not found scattered freely underground. They remain locked inside hard volcanic rock, mixed with other minerals, completely unrecognizable to the untrained eye. A diamond still looks like an ordinary dull crystal when first discovered. Its famous sparkle doesn't exist yet. That brilliance only appears much later, after mining, cutting, and polishing. So before diamonds become symbols of love, wealth, and luxury, before they sit in jewelry stores or crown royal collections, they begin their story as invisible carbon atoms, compressed by the Earth itself, forged by pressure, heat, and time deep within the planet's mantle. This is where every natural diamond is born. Diamonds only form when very specific geological conditions come together. First is depth. Diamonds form deep inside the Earth's mantle, more than 100 miles below the surface. At this depth, the environment is completely different from anything humans experience. Second is pressure. The pressure required to create diamonds is over 50 times stronger than the pressure at Earth's surface. This extreme force compresses carbon atoms so tightly that they lock into a rigid crystal structure. Third is temperature. Temperatures in the mantle range from 1,800 to 2,400 degrees Fahrenheit. If it's too cool, diamonds won't form. If it's too hot, carbon turns into other materials instead. Fourth is carbon purity. The carbon must be relatively clean and isolated. Too many impurities can prevent proper crystal growth or weaken the diamond structure. Fifth is stability over time. Diamonds need millions to billions of years of stable conditions. If pressure or temperature changes too much, diamonds can break down into graphite. This is why diamonds are so rare. Even deep inside the earth, only small zones meet all these conditions at once. When everything aligns perfectly, depth, pressure, heat, chemistry, and time, carbon transforms into the hardest natural material on earth. That's how nature creates diamonds. Diamonds are not mined in just one way. The method depends on where the diamonds are located. 1. Open pit mining. When diamond deposits are close to the Earth's surface, open pit mining is used. Massive excavators remove layers of soil and rock, creating huge step pits. This method is common in countries like Canada and parts of Africa. It's efficient, but it dramatically reshapes the landscape. 2. Underground mining. When diamonds lie deep underground, miners dig vertical shafts and long tunnels. This method is far more complex and dangerous. It requires advanced ventilation, safety systems, and heavy machinery. But some of the world's richest diamond deposits can only be reached this way. 3. Marine mining. Some diamonds are found offshore, beneath the ocean floor. Special ships vacuum diamond-rich sand from the seabed. This method is used mainly off the coast of Namibia. It's one of the most high-tech and expensive mining techniques. No matter the method, diamond mining requires precision, engineering, and extreme effort to bring these rare stones to the surface. Before diamonds can be mined, engineers must locate exactly where they are hidden underground. The process begins with drilling. Powerful drilling machines bore deep into solid rock, sometimes thousands of feet below the surface. These drills extract core samples, long cylindrical pieces of rock that reveal what lies beneath. Geologists carefully analyze these cores to detect diamond-bearing minerals and estimate the deposit's value. Once a diamond-rich zone is confirmed, controlled blasting begins. Explosives are placed into precisely drilled holes and detonated in carefully timed sequences. The goal isn't destruction, it's precision. Blasting breaks massive rock formations into manageable pieces without damaging the diamonds inside. Afterward, heavy loaders and trucks transport the broken ore for processing. This step turns hidden geology into minable reality. After diamond-rich rock is mined, the real transformation begins. First comes crushing. Massive crushers break huge chunks of rock into smaller pieces. These machines use powerful steel jaws and rotating cones to crush the ore step by step. The goal isn't to destroy diamonds, it's to free them from the surrounding rock. Next is screening. The crushed material passes through vibrating screens that separate it by size. Only specific sizes move forward for diamond recovery. Now comes diamond separation. Because diamonds are extremely dense, special methods are used to isolate them. One method uses heavy media separation. The crushed rock is mixed with a dense liquid. Lighter waste floats away, while heavier diamond-bearing material sinks. In modern plants, X-ray scanners are also used. When diamonds pass through, they glow under X-rays and are instantly detected and separated by air jets. At this stage, diamonds are finally visible, still rough, still dull, but now fully separated from the rock. This is how raw stone turns into valuable diamonds ready for sorting, cutting, and polishing. Diamonds come in two types: natural and lab-grown. They may look identical, but their journeys are very different. Natural diamonds are formed deep inside the earth over billions of years. They are created by extreme heat and pressure, then pushed to the surface by volcanic forces. Every natural diamond is rare, no two are exactly the same. Lab-grown diamonds, on the other hand, are created in advanced laboratories. Scientists recreate the same heat and pressure conditions using high-tech machines. These diamonds form in weeks instead of billions of years. Here's the key difference: chemically and physically, they are the same. Visually, even experts need special tools to tell them apart. But when it comes to value, natural diamonds are rarer and usually more expensive. Lab-grown diamonds are more affordable and eco-friendly. So which one is better? It depends on what you value more: natural rarity and history, or modern technology and sustainability. Both are real. Diamonds, just born in very different ways. Diamonds aren't just about beauty. They are one of the most useful materials on Earth. In jewelry, diamonds symbolize love, luxury, and status. Their unmatched brilliance and hardness make them perfect for rings, necklaces, and watches that last a lifetime. But diamonds go far beyond jewelry. In technology, diamonds are used in high-performance tools and electronics. They conduct heat extremely well, helping cool powerful computer chips and advanced devices. In industry, diamonds are essential. Industrial diamonds are used in cutting, drilling, and grinding machines. They can slice through steel, concrete, and even other stones with incredible precision. Diamonds are also used in medical surgical tools, precision lasers, aerospace components. From romance to robotics, from fashion to factories, diamonds power both beauty and innovation. That's why diamonds remain valuable not just on your hand, but at the heart of modern technology. Why are diamonds so valuable? First, rarity. Natural diamonds take billions of years to form deep inside the earth. That alone makes them incredibly scarce. Second, durability. Diamonds are the hardest natural material on Earth. They don't scratch, fade, or break down over time. Third, demand. Diamonds are loved worldwide for jewelry, technology, medicine, and industry. High demand plus limited supply keeps their value strong, but the future of diamonds is changing. Lab-grown diamonds are becoming more advanced, affordable, and eco-friendly. They look identical and perform the same but are made in weeks, not billions of years. So what's next? Natural diamonds will remain valuable for their rarity and history. Lab-grown diamonds will grow in technology and sustainability, different origins, same brilliance, and a future where diamonds matter more than ever.